for Zips Racing. So once you get Altium installed and you have the software loaded up for the first time, you're going to come onto a page that looks like this. So the first thing you're going to have to do is set up your account. So for reference, account management is stored in this top dial here with your profile icon. And then the way that we kind of handle who gets to use the software is through license management. So I don't know why this is taking so long, but once this will load here, you'll see a menu with our license for the team and then the number of seats that we have in the license. So this is kind of the number of people that are actually able to use the software here. So you can kind of see right now I'm the only person using our seat, I'm the only person in our license right now. And then whenever you're designing a circuit board, you'll take up another seat, of course, to use the software. And then additionally, we have a workspace too. So whenever you first log in for the first time, this should just be black, like a black cloud here. And the first thing you're going to want to do is click on the Zips Racing Electric Workspace. So the workspace is where we store all of our PCB projects, a lot of our documentation, and all of our circuit board components. And kind of giving you an idea of what is in that, we can kind of pull up this tab here. So the way Altium is kind of structured is you have a main panel here. So that would be this thing saying license management. And then you have your projects bar, and you can put other stuff here as well. And then on the right is kind of your selection pane. And you can modify that by clicking panels. And you can kind of see, you can pull up components as a tab. And these are basically just, like right now I have something searched, and you can kind of just see a list of components we have. I don't recommend using this window. I would use the Explorer window, and you can kind of select components here. So these are kind of all the circuit board components on our car that we have in one place here. So once you get into this Zips Racing Electric Workspace, you can right click on this cloud icon here and open a new project. And what that's going to do is that's going to bring up our workspace. So you can kind of see every single circuit board that we have here. You can also filter by stuff that you've messed with recently, shared projects, and then just, local projects on your computer as well. I would recommend doing everything through the cloud. That way, you can constantly back stuff up. So, if you forget to save something or something happens to your computer, you're not going to lose out on all of your work for the project. But it's kind of a reference here. I'm going to pull up the ST-Link board. So yeah, like that, you can right click and open a project, and that'll get you into a project into Altium Designer here. So let's pull up the schematic for this. So this is basically a integrated debugger circuit board for the microcontrollers on some of our vehicle control boards and that sort of thing. So we can kind of take a look at that here. So it's just a pretty simple board where you just have this module, and then that connects to this connector here. And then that actually goes to boards that we program. So this is just, a tiny little programmer. So kind of looking here, like I was saying, you have your projects panel here. So this contains all of your source documents for the PCB project. So, your schematic files here in yellowish, and then your PCB file here. And then in addition to that, you also have a bill of materials document. We'll wait for that to load. It tends to take a while. And this is kind of how you manage what parts are related to like what components, right? So this is like ST-Link V3 mods, right? So we can kind of click on that and get some more information about that here. You can actually see the footprint for that. And then that is connected to this BOM document here where we can see ST-Link V3 debugger mods. And then we can actually just go and order that through this BOM document. And then there's also some other documents associated with the project as well. The out job is something that you're going to hear a lot. An out job file basically is a way to expedite the generation of all of your manufacturing files. So let's say, we finished the schematic and the PCB design, and then we get to this point where we have an out job file. This file is going to let us actually, generate everything. And it's really nice because, all you have to do is just hit generate content, and it'll generate, let's see here, it's generating a step file, which is step is like a CAD file structure. So like if we were going to hand a circuit board we designed to mechanical engineering to make like an enclosure or something, we would send them this export step file, and then they can design their enclosure around it. And then our Gerber files and drill files, which is what we're actually sending to our circuit board manufacturer. And then those just go into a folder together, and then we zip the folder and send that to the manufacturer. And then a bill of materials that we can use to actually order all of our parts. And then we can filter that by, like what supplier do we want to order with and that sort of thing. So, yeah, going back into Altium here, I want to kind of show some of the symbols that you're going to be interacting with a lot. So, first of all, is going to be your power rails. So, power rails in Altium are kind of what you'd call a unique net. So a net is basically any electrical signal with some name ascribed to it. So like right here, it's SWCLK for the clock. And here, we can see our power port here. So that's a 5-volt power rail. And then down here, we have a 3-volt power rail. And going into our PCB design here, we can go into 2D mode, and let's see if we can find some of those. Yeah, so here's our 3-volt net here, our reset net, our clock net, that sort of thing. So whenever you are designing a circuit board, you always want to name these nets. In the past, our team has kind of been sloppy with that. And for instance, like let's say I get rid of software clock, in this PCB designer, that will just be named like some garbage whenever I go and actually update it. And that makes circuit board routing very hard, because if you have I can actually pull up a board to give a better demonstration of that. But if you're opening up a circuit board and you have let's say 10 nets all routed next to each other, and they're named like net J1, net J40, net J, whatever, it makes it extremely complicated to kind of figure out what is going on. So you can kind of see some of that here. There's, what's that, 4, 8, 10 nets going there. And then you also have 8 other nets on other layers below it. Just kind of naming things is a very good way to keep track of what you're actually working on. And you can do that by going to place and then net label. And then you can kind of see here, it's defaulting to whatever you give it. So you can leave parameters. So if you wanted to call it out 0, the software actually increments it for you. So let's say you're going to some sort of 8-bit interface where it's all the same thing. It'll just increment all of that, which is pretty nice. And another thing to take notice of is here in these menus, let's go back to that place menu here. So you can see kind of that the P is emphasized with that underscore on it. So what that means is we can actually just access that menu by typing on the keyboard. So P, that just pulled up that same place menu. And then net, you can see here that N is accented. So we can just hit N again, and then boom, we have our net. Delete that. Yeah, so any kind of thing in Altium has a shortcut for it. We can go back to that place menu again. Some other ones that we do are placing a wire, right? So if you want to connect 2 things together, you do that by hitting Control W, and then you can see this little cursor gets brought up, and that'll let you route a wire. So you can do that to connect, 2 different things together, that sort of thing. That's probably the keyboard shortcut you'll interact with the most. And then some other things beyond that is these power rails I was talking about earlier. You access them through this top bar menu here. And this kind of serves as a good shortcut for anything important that you want. So let's say I want to place a ground. You can just grab it from there. I want to place a 5-volt power port. I can do that there. And kind of one thing to note here is that the default ones ascribe just 12 and then the voltage. For all of our circuit boards, we add a V to it. That's just kind of engineering relic and a standard that we just kind of stick to. But yeah, and then further on through there, you can kind of get a good look at, you can place text, you can have it say whatever you want. You can place a note, you can type about it. And then there's also shapes and some simulation stuff that we don't really do just because we very recently got the licensing ability to even do that. So it's not something we've really kind of looked into that much. So I'm going to jump over to the power distribution board to kind of give a more in-depth understanding on some of the circuit board stuff we do here. So kind of taking a look at this is going to be one of the more complicated circuit structures. So this uses what's called hierarchical design. So the idea with hierarchical design is in a kind of engineering system, right? You'll have your high level like inputs and outputs, right? Like I'm inputting this thing and I'm outputting that thing. And it's just a block that you just describe that to, right? But, there's a lot more that goes into that block than just that one thing, right? So for instance, let's go to the power management block here. So this just takes in an input from the microcontroller, and you can kind of see here, these are everything that's actually going to it. So all of the fusing statusing, all of the current sensing, diagnostic enables, and then inputs. These are all going into this power management block, and then it's outputting 12 voltages, 0 to 11. For reference, we start counting at 0 for all of electrical and computer stuff if you're not familiar with that yet. And that'll go to these outputs here, 0 to 11. And then we can find this block here. You can either right click on it and then do sheet symbol actions, open subsheet, and that'll pull up what's inside there. Or you can just look at your project panel. Right here we can see power management, and right now we're in that smaller block. So you can see all of those inputs that came in here. And then you can also see that in this block, we have 12 sub blocks. So these are all of our power switches and stuff. So these basically are, what is our level 1 layer of abstraction, where that previous layer was level 0. And then we can actually open that block, and that'll show you this is what's actually in the block. So those 12 circuits are just these integrated circuits with these circuit components. And this kind of design is probably one of the more complicated ones that you'll see. It's only been fairly recently that we've started actually, interacting with hierarchical design. The main benefit to that is that it's a lot more repeatable, and you can lay out components and just copy them. So whenever you're designing a PCB, if you have 5 circuits that are the same thing, you only have to actually route it like once, which is super convenient, and it'll save you a lot of time if you kind of get comfortable with using that correctly. So this is what a board looks like if it's not designed hierarchically. You kind of go in a system of arranging sheets, right? So this is like our project revision table. This isn't really something we use that much, and I'm probably going to remove it from the template just because it's not very useful, and it relies on these things called project parameters. So it's a huge pain to kind of go and fill all those tables in. But basically, you can see that this is our vehicle control board for the current car, and this has that's something I was wanting to change, but this has 2 pages effectively. STM32, which is our microcontroller. You can see all the circuitry for that here, and then our pump and fan control here. So kind of we'll start with a power regulation circuit here. So for reference, our car runs off of a 12-volt battery at the moment. We're going to be transitioning to 24 volts next year just because you can use smaller wire. But one of the things that kind of every circuit board that you're ever going to see is going to have is some sort of power regulation circuit. So microcontrollers run anywhere from like 1.8 volts to 5 volts. So since we're getting that 12 volt in from the battery, we have to regulate that down to that voltage. So the way we do that typically is we do a 12 volt to 5 volt regulator. So this is a component that you can just buy, and then you need to add some additional filtering capacitors here. So you can see we have 2 10 microfarad caps here as well. And whenever you're kind of designing circuits like this, you kind of want to go to, let's go, I guess I don't have that on here. You're going to want to find the data sheet for these. So you can kind of just copy the part number. We can go to Octopart, let's say. Octopart's a good place to get data sheets for parts. You kind of just throw that in, and then we can see our data sheet here. So you can kind of see here a typical application here is those two 10 microfarad capacitors. And this is kind of your data sheet. For all these parts, they all have a data sheet ascribed to it. And then beyond that, you have your sort of application notes too. So I would consider like this page here to be your like application notes for how do I do this. And then a lot of times with power regulation circuitry, you'll see like EMI filters. We don't really do that just because it's extra components you have to support for kind of very little tangible benefit along with that. It might be something we look into in the future just because EMI has been a little bit of a problem this year since going to 4 motors, but not enough for us to kind of justify looking into that just yet. So let's look at this circuit again here. So we're taking 12 volts in. This is just an LED here. So our resistor and diode. If you're not familiar with this, a diode basically will create a voltage across it, and we want to limit the current that can go through it. So what this resistor is doing is effectively choking the amount of current that can go through the diode, right? So if we just connected this to 12 volts, it would blow up. So we need some way to limit the amount of current that'll go through it. And then the idea is just whenever we have this circuit board in-house and we turn it on, if this light isn't on, that means we're not getting 12 volts. Or say if this light isn't on, that means we're not getting 5 volts. And then this is called a TVS diode here. So this is just a protection circuit that we put on all of our boards. So basically if you plug in power backwards or apply a voltage that's too high, it'll blow and it'll protect everything in the circuit. We do that on basically any circuit board that interacts with the main car battery, just because people in the past have plugged in stuff backwards and caused a little bit of havoc. But it's just a good precaution to have, and it's good engineering practice to have that sort of stuff. So let's kind of talk about how we can place components, right? So right now we're kind of in our schematic editor, right? And we want to design a schematic, and then we want to convert that to our PCB software to actually lay out that. So I will start in Explorer. Let's say we're looking for a resistor. We're going to go to resistors, and then we have a generic folder. Let me pull this pane out a little further so I can give a better demonstration of what we're working with here. So you can kind of see the main folder is unorganized. This is something that you're going to notice a lot as you get further into this, is some of our file organization isn't where it should be. And that's kind of a consequence of not having enough people, that sort of thing. But I've been working on that recently, and a lot of the components that you would use daily are kind of in a state that's a lot better. So for instance, let's say you want to place a 1 kilo ohm 0603 resistor. You're going to right click from this Explorer pane. If you don't see that, you can hit Panels, and then Explorer will come up, and that'll actually pull that up. But you're going to want to right click and place. And then here you can kind of see it'll bring up this menu. And then let's say you want to rotate it to face up. You press space to do that. And you can go through all your orientations here. And then we can add a wire by pressing Control W. And then let's say we want to ground it. We'll press that ground and do that. And then let's say we want to place, I don't know, let's find something here. Let's place a diode. So let's say we want to place, let's place this LED. We're going to right click and place. And then that'll come up in this menu, placed. And then another thing to note is whenever you like do that, it'll pull up another one. You just hit escape, so you're not having to add more diodes. And then we can connect those together. And then let's say we want a power rail. You can kind of just do Control C, Control V on these, since the default ones are like this. So if you do plus 12 and plus 12 volts, these are different nets, right? You're naming them two different things. This is plus 12V and this is plus 12. So you kind of want to make sure that you don't do this. And this was actually a problem in some of the early circuit boards I designed, where I didn't really follow the design convention of plus 12V and I did plus 12. And then you kind of have the nightmare of, if you don't catch that and you order that circuit board, you now have two 12-volt planes effectively. And you need to figure out some way to connect them together with wire, which is a huge pain. And it's not really something you want to find yourself doing. But yeah, so from here, you can kind of press your keys and connect stuff together. So, right now we just added another LED on the 5-volt rail. And then we can save that. And then whenever you move to a PCB, you want to do what's called validating your project. So what that's going to mean is we can right click here, and your first option is going to be validate PCB project. And we click that, and that's going to tell us what is wrong with our project. So we have warnings and info. So the thing it looks like we're seeing is component revisions are out of date. So that's because this board was actually made months and months ago. So components kind of get updated since then. General practices is when you're building a board, and if these are out of date, you're going to want to update these. And then, yeah, it looks like our only errors are that. And then undesignated part number. So another thing that we do when we design circuit boards is we assign every component a number and a letter. So for instance, resistors, you can see like this is R5. This is C20. This is PS1. There is a kind of rough, loose standard of what letter gets defined to what. And you don't have to do all this by hand. So you can see that these came in as like DS question mark and R question mark. So we can go to Tools, Annotation, and then we can hit Annotate Schematics. And this is our annotation manager. So this kind of does all of the part number assignment and stuff for you. So all you really have to do is update changes list and then hit accept changes. And now you can see returning DS question mark into DS5 and R question mark into R8. And that's actually going to just define that. So then we can hit execute. Don't worry about these options. You're just going to hit execute, and we can close that. And now we have DS5 and R8. So we'll save that, and then we will hit design and update. So you can see, like I was saying, DU is the keys. So you hit D, U. It's going to load, and then it's going to tell us the changes that we're making. So we'll hit execute. And then we just added two new components. So you can see R8 and DS5 right here. And there, you can kind of see, use spacebar again to mess with that. And then I'm going to hide polygon pores here to give a better idea of what's going on. And then basically, it's similar-ish to the schematics. I'm going to do a separate video for everything explaining PCBs, because this is a whole nother thing of figuring out, what kind of general practices I want to follow. Like for instance, how thick do I want to make my traces? Or, how do I set up these polygon pores like this, right? You can see that some of these are a little weird, right? Like this one, and then this one is just a straight pore. And then, yeah, so a lot of it's just kind of getting familiar with this sort of thing. And we'll do this in another video just to make sure it's something separate, since I've been going on for nearly 25 minutes now. But I kind of hope that gives a basic overview of the kind of stuff we work with here. I know like this circuit appears to be pretty overwhelming just because of how much stuff is on it, but this is something that you kind of pick up with time, right? Like whenever I started looking at this, I was like, I have no idea what I'm doing here, but you get a feel for it. And we try to make things more portable. So, like for instance, this microcontroller is used on like 6 or 7 boards in the car. So, you don't really have to become familiar with, what do all these filtering capacitors do? What do these tank capacitors do? Right? You can just kind of copy and paste it, which I know sounds lazy to some extent, maybe, but if you spend all of your time finessing over kind of stuff like this, you kind of forget the big picture, right? That we're doing this for a race car. So, having the best, I don't know, tank capacitor selection doesn't really matter as long as it works. And that's kind of a motto for a lot of this stuff. But that's not to say, having good design practices isn't important. It absolutely is. And during the kind of manufacturing season, if you don't think about your manufacturability, you're going to have some late nights and possibly a system that doesn't work. But yeah, I'm gonna call this video here. This was kind of meant to be a overview of kind of navigating around Altium and the schematic system of Altium as well. Thanks.